Hey AP Calc students, this is Melody, and today I'm going to show you the differences between shells and washers on the x-axis and y-axis, and when you should use them both. Sorry, this is a little ghetto. Doing this by myself, so I don't have anyone to tape it for me, so this is why I'm doing it on a piece of paper. So let's talk about washers first. And let's talk about them on the x-axis. So when we're doing washers on the x-axis, that means we're revolving around the x-axis. So here's a little coordinate plane. And we're revolving around the x-axis. And we're integrating from a to b. So let's say we have two functions. The one on top is going to be f of x. Sorry, guys. And then the one on the bottom is going to be g of x. So every time we do this, we draw a little rectangle, because Cresswell likes to do that. But also, it's really helpful because when you try to think of like this whole thing from A to B, this whole like little section, it's hard to like visualize it going around. So if you have this little rectangle here, it's easier to understand it. So you're like going to be coming down here, and it's going to be like that. Yeah, Cresswell draws it weird, but it's okay. So how I like to think of it is this is the big radius, so we do a big R. This is the little radius, so it's little r. And so you're kind of making like this little cylinder thing, like that. Really ghetto. But so this will be like little r, so this is why there's a gap right here. And then big R is this part. Okay. So the equation for that, when you're trying to find the volume and you're rotating around the x-axis, is pi from a to b, parentheses, f of x squared minus g of x squared dx. I don't know if you can see that. Alright. So that's fine, and when you're writing your equations, they're in terms of x because you're rotating around the x-axis. So that's for washers. If you're doing it with shells, it's a little bit different, and this is where it gets a little confusing, so bear with me in my ghetto notes. So here's a coordinate plane. Ugh. So now, when we're integrating, instead of from A to B on the x-axis, we're still rotating around the x-axis, but we're thinking of it from C to D on the y-axis. So let's say we draw our little equation here, and we'll call that f of y. We're still rotating around the x-axis, however, we're going to refer to it as f of y. And so we draw our little rectangle there. So we're rotating around there. And so this width right here will be dy. And so if you want just a simple equation for that, and this will be true for all shells around the x-axis, you're going to go from C to D on the y-axis, and you're in terms of y. Now, it seems a little redundant, but the reason why we do that is that when an equation is given in terms of the opposite variable, so like it's in terms of y, but you're rotating around x, sometimes it's really hard to get the variable to be in terms of x if you're rotating around x. So it's easier to keep it in y. It's like for power functions and stuff like that. So we're going to write an equation, v equals 2 pi from C to D of y, f of y, dy. Alright, kind of looks like a d. Yeah, so when I was kind of learning this, it's hard for me to understand. So Cresswell introduced it in a different way, which I thought was pretty helpful. So here's a different way of looking at it rather than just, you know, dy, f of y, because you don't really understand, it's hard to understand like where this is coming from And when you're like rotating it, it becomes like a shell thing. Cresswell draws it better than I can. Hard to believe, but it's true. So here's another coordinate plane. We're gonna, here, let me just draw this really quick. Got our rectangle. Okay, so we're gonna add a lot of different letters in here, but bear with me because I find it a little bit easier to understand. So we're still going around the x-axis, and we're still using the shell method. So we're still gonna go from C to D. So when you think of it, this right here, this length, is the height of this rectangle. So it's going to be h of y, because we are in terms of y. And then p of y is this right here. From the middle, this is like supposed to be the middle of this rectangle. And then this right here, this little itty bitty width, is w, or the change of y. And so when you look at it this way, the equation becomes 2 pi from C to D, P of y times H of y, in parentheses, dy. Y. Okay. So either way is right, depending on how you learn or how you understand things. You know, you might like this method better, you might like this method. For me, when I'm writing equations, I find this method to be easier because right here you're kind of just like, sometimes you're kind of guessing of like, wait, what's the function, you know, in terms of y, blah, 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 trying to find the derivative and everything. It's just easier for me to do this way, but the choice is yours. So that's the x-axis. So here was washers, and then here's shells. And then I will explain the y-axis in the next video, probably down below the page. So click on that video for the y-axis. Thanks, guys.